All right,
Just like can't.
let's go.
I don't know why that is, because I was just dancing.
Okay, guys. I got to teach you over here because my iPad is dying. So here we go. My iPad's like, I've had a long day at work. Leave me alone. Guys, something that is incredibly important. Are you ready to highlight or circle or whatever? Something that is incredibly important.
Yes. Yeah, that's probably why.
Properties of logarithms.
Mitchell?
Okay. Oh, snap.
You broke it?
No, I was
Standing here, the culprit.
Who turned it off?
Right.
You.
Oh, it was me. I reached out to him.
Does anybody have a charger?
No.
Mitchell has your over there.
Mitchell has chargers.
Speaking of which, can I charge my phone too?
All right, let's try this again.
Got less than an hour left. We got 53 minutes.
Okay. Ah, we're chilling, man. All right, you guys. So it's coming on right here. Properties of logs. We have talked about this enough, but this is probably the most important thing that we're going to use in calculus, okay? Now, I told you at the beginning of the lesson what kind of inspired me going, oh my gosh, we have got to go over E's and LNs and properties of logarithms, right? Aside from the fact that you guys are amazing. All right, look.
Hey, Mitchell, I did good.
Okay.
Hey, I just forgot to factor something out.
Guys, if you multiply, you can separate the logs and add. Now, there's a reason in calculus why we really like to do that. And it has to do with derivatives. Any idea why we love that?
Because you can
Don't do a product rule.
Yeah, oh, Len, what do you got? Yeah, dude, we have to do a product rule with that. We freaking hate product rule. But if I separate to that, I can do them separately.
Mitchell, where's your Chromebook charger?
In the back somewhere, I don't know. Okay? I don't know.
Been really fast.
If we're dividing, I would have to do a quotient rule right there. I don't want to do a quotient rule. But if I separate it out, I can do them separate. This one is really important because the 3 questions that I showed you guys at the beginning of class. Let's go back and look at it. Okay?
Ow.
Zach, you were here. I was doing this question from your guys' test the other day, part 2, because I'm grading it tonight. And my answer was the ln of the absolute value of -1/5.
Oh, yeah.
And the only choices were ln5 and -ln5 that were even close. And like, I knew I did that right. So I was sitting there like, dude, what the heck? So let's think about this real quick, okay?
Abby knows.
We already have absolute values.
She really wants to explain it.
Abby, let's go. It's your moment.
This is
You
it,
got
Abby.
this.
No, you got it. Go, go. So you can separate it into ln of -1 and ln of 5.
Oh, I like that. Now, I just took off the absolute value of the negative, but that's good. You can separate this to ln1 minus ln5. And what's the ln of 1?
0.
Where's the negative?
0.
Oh my gosh.
It's negative.
0 minus ln5.
Right?
Yeah.
That didn't make any sense.
No, but if you had ln of 1/5, that's just division. You can split it up, but it's -1/5.
Right, but I was doing an integral problem, and you know when you
Oh, it's
integrate, it's
absolute
ln of
value.
absolute value.
So it doesn't matter.
So I could take off the negative.
I didn't look at that at all. Okay.
Yeah, so it was an absolute value because it was an integral problem. But just from that point, it's ln of 1/5. Here's another way, you guys watch. ln of 1/5 is the same as writing ln of 5 to the what? -1, right?
Oh.
5 to the -1.
Yeah.
Can we bring exponents down in front?
Yeah.
Right?
I don't know what she just did, but Abby's way was simpler.
Yeah, okay, this was because I did an integral, and if, like, in AD we haven't done integrals yet, but basically when you do an integral, you put an absolute value right here, so this turned into a positive.
We laughing.
So that was the first thing that confused me, but that turned into a positive, and then you guys, I said, oh, well that's 5 to the -1, they can do that. Okay, same thing on this question on the AB test from last time. And you guys took it 2 in BC, it was like chapter 3, right?
I remember getting this one right.
You got it right or wrong?
I got it right.
Because we did the problem and we got 3 ln3, which was perfect. It was this question, if you guys remember it. It was this. It was y equals 3 to the x, find y prime of 1. Okay? You guys remember?
Yeah.
What's the derivative of 3 to the x? 3 3 to the x times ln of the base. Right? So the derivative of a to the x is a to the x times ln of the base.
It's okay.
Okay? And when I evaluated at 1, I got 3 to the first ln 3, and everyone was like, woohoo! Like, everybody did that part right, practically. And then everybody marked the wrong answer, right? Because it's a log property. So 3 ln 3 is the same thing as 3 to the third.
Yeah, I was just saying.
And 3, hey, relax, I got it. And 3 to the third is not 9, 3 to the third is
I
27.
think I wrote that right, but I think I
Does that make sense?
I think I got that one wrong.
Okay, here's one more I'm going to show you. When we do an integral of sine over cosine tangent, when we do an integral of tangent, okay, if you're an AB, just don't worry about this part real fast. We're going to get to it, but
It's fun.
tangent sine over cosine, right?
Oh, wait. Can you explain the one where we had to have like this sort of accumulation, but it was like
Don't worry, you'll find out. You'll feel so
no, but it was
fancy
like
after.
you took the derivative, it was like tangent, and then
Doesn't it need to be-
Actually,
integral
we do feel
tangent.
that.
Yeah, so I did negative.
Sorry.
So it's negative 1 over u du, so it was negative ln u. So it was negative ln cosine, okay?
Oh my gosh, I'm missing you.
Now, I was doing a question the other day, plus C, right? And it was from an old AP test. And that answer was not there, okay? But this is the answer that they put. And I was like, that is freaking mean.
Disgusting.
So why?
Because you can put it to the negative 1. And
That negative right there can translate up here. And cosine to the negative 1 is the same as 1 over cosine to the 1, which is...
I don't like that.
I don't like it either. But they do it on the AP test multiple choice. So they're like, hey, good for you, you know the calculus. Good job. You don't know your algebra, you did it wrong. You see what I'm saying? It's crappy.
And that's why we're
That's the calculus.
Is it recording or no?
Yeah, it is. But that's it.
It's low battery.
Oh.
Oh, my iPad or that thing?
That thing.
Oh, for frick's sake. Put it in low power mode then. Okay?
Does it not charge it?
I don't know.
Where would it doesn't have a cord, no?
I don't know.
Power from anywhere.
Guys, this is why
it takes
these are
power?
super important.
We should have a cord.
I'm going to show you guys one other thing real quick
Oh, it
here.
might have.
And then we're just going to do a bunch of examples, all right? Okay, but I'm going to show you guys one more thing. This one isn't even charging. Ooh, because I'm pulling away from the wall. All right,
I'll probably leave.
check it
I'll
out.
probably leave.
Find some space somewhere.
Somewhere.
Yeah.
You should be.
Okay? I want you guys to take the derivative of that. Right? Now, does that look like the biggest nightmare ever?
I'm just not.
Because it's a chain rule, so I have to do 1 over, because
That's
the
like
derivative is
15
1
chain
over.
rules, dog.
And then I got to do a product rule with a quotient rule. There's a little baby chain rule in
Wait,
there.
no,
with
but you want to
square
split them up first. ln of that minus
Right.
sine of x. Or ln of sine.
This is one of the biggest reasons why we like these ln properties. Because I can rewrite this,
Is that
okay?
a 5?
Yeah, x minus 5. I can rewrite this. ln of x squared, right?
Yeah.
Plus
What?
ln of square root
That's why I'm
minus ln of sine.
What is the ln of sine?
Hold up.
Yeah, and then it's even better than that, you guys.